Alright, we got 2 times the square root of x plus 1 equals 4. Okay, so it's all pretty simple, and I think it's all pretty simple. There's a couple of things that has a hairy step in it, but this is pretty good stuff. Y'all do well here. Try to solve for x. Okay, when we've got radicals involved, that's what that square root, remember that's the fancy word for the square root symbol. We got radicals involved. First thing we're going to want to do is get rid of any extra junk that's not a part of the radical. If there's something that's being multiplied, like in this case, or if there's something that's being added or subtracted on the end of it. So in this case, we've got a 2 being multiplied by that radical. So that's going to be our first step. Clear that out. We want to get the radical all by itself. We say, in middle school, we started learning to say isolate the variable. Well, here the variable is part of that radical, so we're actually isolating the radical, getting the radical all by itself. So divide both sides by 2. Okay, cancels out over there, just leaves you with the square root of x plus 1 is equal to 2. Okay, now I'm trying to solve for x. This whole piece is being square rooted. How do you undo a square root? Square it. So we're going to square the whole thing. Okay, when I square the square root, what does a square and a square root do? Cancels out, so you just got x plus 1. And then when I square the 2, 4. So look, you got like a baby equation there. What do you do to get the x all by itself? Subtract 1.
You could just tell by looking at it.
Yes, you could. X equals 3. Now what Kylie's talking about, when you got to this level here where my mouse is hovering, you know to get a square root that equals to 2, it's got to be a 4, right? So what could you put in there to make that 4? So it'd be 3 plus 1. So you could have gotten it looking at it common sense wise there. Pretty easy. I like that. Now, today we're going to learn a new term, and it's called an extraneous solution.
A lot of people make work out that.
What an extraneous solution is, they're not friendly. Because an extraneous solution is when you do all the work mathematically correct and you get an answer mathematically correct, but then you plug it back in to check and it doesn't work. So it was like all that work for nothing. It's no good. It's an extraneous solution. So we're going to have to start checking our work today to make sure things are right. This one you could tell common sense it was, but let's plug it back in the original up here and make sure. 3 plus 1 is 4. You following with me? 3 plus 1 is 4. What's the square root of 4?
2.
And then times 2. 4, and that's what it said it was. So this one's okay. 3 is right. But if this had ended up like saying 3 equals 4, that's not true, right? So it'd be an extraneous. And we'll see some of those in a little bit today.
So if you were writing a definition for that, what would you put? Like, answer doesn't work.
Answer doesn't check, yeah. Alright, we got what we need on that page. Let's do another. We got 2 cube roots of 2x minus 9, and then minus 1 is not underneath the radical, is equal to 2. Okay, trying to solve for x, and we'll get the radical all by itself. The first problem that we did, we had extra junk being multiplied. This time, it's got extra junk being subtracted, so I need to get rid of that. How do you get rid of a minus 1? You add 1. See, y'all already know how to do this. Gets you the cube root of 2x minus 9 is equal to 3. Now, this one's a little bit harder to see the way Kylie saw that last one. You could play with some numbers here, because there's only one number that I can cube root and get 3. 27, right? In the cube root of 27, 3. So I could do some mental math and play with that to see what would make that 27 underneath there. I could. Might be just as quick to just go ahead and solve on this one though. So how do I undo? I don't have any more extra junk. How do I undo a cube root? Cube. Very good. So the cube cancels out the cube root. So you just got 2x minus 9. And 3 cubed, we just said 3 times 3 is 9, and 3 is 27. Look at there, you've got a 2-step middle school equation to solve. What would our step 1 be? Add that 9 x is 36, then what? So that means x is 18.
That's what
Everyone just look at you like, what?
I know. I can feel it. Like I saw it before in my eye.
Alright, does that check out? Let's go back up there and plug 18 in and see what happens. Alright, 2 times 18 is 36. 36 minus 9 is 27. Alright so far? Cube root of 27 is?
3.
And 3 minus 1, does that equal 2? Yep, so far so good. It really just makes your work longer. Because now you've got to go back. I haven't always required, I've not been a good teacher, I haven't always required you to check. Now we have to check. So, did you ever have math teachers that made you check every one? They're better than me. You didn't have them? Really?
So what happens
Should.
when you get a extraneous solution?
It would have, we would say it has, oh, let me see. No solution. There we go. 5 times each one. When he knew that it was possible, so yeah. Alright, let's look at here. I got, oh, this is adding a step here. I got x plus 1 equals the square root of 7x plus 15. Alright, so we've been isolating the radical, getting the square root all by itself. Over there on the right side, it's already isolated. There's nothing extra stuck on any of the ends of that radical. Right? So our next step after we isolated the radical was we cleared it out. We got rid of it.
You can square it?
So we have to do that square root by squaring it. Now that is going to cancel out here, so it's just going to be equal to 7x plus 15. But over here, that doesn't mean x squared plus 1. I'm not just distributing the squared to both of those. That means I have to take x plus 1 twice, doesn't it? Remember that? Lots and lots of people will forget that. They'll just try to distribute the squared to both of them. No, no, no. No, no, no. No, no, no. FOIL now. It's x squared. Outer's 1x. Inner's 1x, so that's a total of 2 x's. And then last is 1. We're still equal to 7x plus 15. Okay, so what's new this time? We've got a quadratic. So that means we could possibly have 2 answers. We could have 2 answers, 1 answer, or no answers, right? So I need to, how do we solve quadratics? What do we always have to set it equal to?
0.
0. Good job. So let's subtract 7x from itself and its buddy. And let's subtract 15 from itself and its buddy. It gets me x squared. 2x minus 7x is negative 5x. 1 minus 15 is negative 14.
They just do a quadratic formula?
Okay, now, all the ways that we learn to solve quadratics. Quadratic formula, factoring, completing the square. If it'll factor, that's my preference. It's a little bit easier. Quadratic formula will always work, though, if you want to do that. Factoring, we check and see a times c is negative 14. Are there any factors of negative 14 that add to negative 5? Negative 7 and 2. So this is going to be x minus 7 times x plus 2 is equal to 0. Some of y'all can skip that step and just already know your answers, but I'm showing my work because I already feel bad I don't always make you check. So x minus 7 equals 0. Add your 7. X plus 2 equals 0. Subtract your 2. Alright, I'm going to write that original equation down underneath here so we can see it all when we go to do our checking. X plus 1 equals the square root of 7x plus 15. Alright, which one do you want to check first? 7. So 7 plus 1, I got to plug it in both spots. 7 plus 1, square root of 49 plus 15. 49 plus 15 is 464. Square root of 64 is 8. So 7's good. Everybody okay there? Okay, negative 2. Negative 2 plus 1 is negative 1. Now, I already know that can't work. Because I can't have a square root that equals a negative, can I? Let's go ahead and plug it in anyway. 7 times negative 2 is negative 14. Negative 14 plus 15 is 1. Square root of 1 is 1.
So it's just x equals 7?
So x equals 7 is our only one.
Is it like sometimes will both of them work?
Yeah.
Okay.
Alright, all pretty simple, easy going so far. Now this next thing is where, when I was telling you, it can get a little bit sticky sometimes. We're going to have a radical on both sides. Okay, so you ready? Got what you need on that one? And this is the hardest kind that we'll have today, so this is not very difficult. I've got the square root of x plus 2. Hey, I need to go back. Okay. Yes. That one that we marked out on that would be considered the negative 1, or negative, it was negative 2, yeah. That would be extraneous, yes. So if you ever have anything that asks you to identify extraneous, that'd be one that you get and plug in and it doesn't work. And somebody, Algebra 3 is not doing the same thing right now. They're doing rational stuff, but we had extraneous solutions with them today as well, and one of those kids told me that they had that on the ACT last time they took it. Like had all these number answers, A, B, C, and then D said extraneous solution. She didn't know what it was. No, because x equals 7 is a real solution. So if it just asks for the solution, it'd be x equals 7. If it asks for extraneous solution, it'd be x equals negative 2. Most of the time, you just ask for the solution. So you would just forget all about the negative 2. Alright. Here we were looking at square root of x plus 2, and then plus 1's not underneath it, equals square root of 3 minus x. Alright, so before, our first deal was to get rid of extra junk. But I hope you see that as a problem here. Right, on the left side I've got that plus 1, so if I subtracted it to get rid of it here, wherever you do on one side, you got to do on the other side. So that would just be moving the extra junk back and forth. It's still going to be there somewhere, isn't it? It doesn't go with anything and cancel out. So after that, our next thing to look at was just getting rid of one of the radicals. Now we have to have one of the radicals all by itself. So in this case, this one is already all by itself. So this is the one that I'm concentrating on right now. Okay? So since that one's a square root, how do I undo a square root? Square it. So we're going to have to square that whole thing. Now, you're going to have to stay with me here. This is as hard as it gets today, so stay with me on this. The square root here does just cancel out, yes. So that side is just going to be 3 minus x. Over here, though, that extra plus 1 piece does not let it just cancel out because this is actually now a binomial. It's a big looking one because that radical is big and scary looking, but this is like your x squared plus x. You know, that's a binomial. So when we square that binomial, you've got to write it twice and FOIL it. Okay? Square root of x plus 2 plus 1. Square root of x plus 2 plus 1.
Whoa.
This is okay. You can handle this. Alright, so we start with our FOIL, here I've got, on the first, I've got the square root of x plus 2 times the square root of x plus 2. All right, let me ask you this, because this is going to be easy once you realize it. What if I had, let's throw something that we're good at. What if I was doing the square root of 3 times the square root of 3? It'd be the square root of 9, which is 3, right? So those square roots just end up canceling out, right? So this is the same thing here, because x plus 2 and x plus 2 is the same, just like my 3 and 3 was the same. So what's going to happen when I FOIL that to those radicals? Cancel, they're gone. So that's going to end up just being x plus 2. So after my first, I had x plus 2. Now, I'm not going to cancel out on these other pieces. Let's look here on the outer. Square root of x plus 2 times 1 is just 1 square root of x plus 2. Right? Because we just multiplied it by 1. It didn't change it. Same thing on the inner. 1 times the square root of x plus 2 is just the square root of x plus 2. And then your last 1 times 1. Alright, I told you every time we FOIL, 95% of the time you can combine like terms in the middle. You can do that here as well. What is the square root of x plus 2 plus the square root of x plus 2? Good. This is one of them and one of them, right? So one of these plus one of these gives you 2 of those. Treat it just like a variable. We talked about that earlier in the week. So that's going to make that be. I've still got, just bringing this stuff down here, I've still got that x plus 2. And then I got plus 2 of those square roots of x plus 2. And I still got this plus 1 over here. Now remember, we're equal. I've got it written up here where my mouse is fluttering right now. Don't forget that. We're going to have to bring that down here in a minute. Alright, let's combine like terms over here. I've got a good old 2 and a good old 1. Those are just plain old buddies, aren't they? So that makes me have an x. Bring that x down. I'm going to bring this piece down. Oh, bring it. What order did y'all write it in? Did y'all write 3 next?
No, now I write 3 at the end.
Okay, so plus 2 square roots of x plus 2, and then plus 3 equal to 3 minus x. Okay, if you compare that back to what we started with, we're down to 1 radical now. We started with 2. So that was the whole purpose, and everything that we've done so far was to get rid of one of those radicals. So now we're going back to what we began the day with. If there's any extra junk on our radical, we're going to get rid of it. Okay, so first thing I'm going to do there, and if you go in any order, I'm going to subtract the 3 from itself and its buddy. So that'll just bring down my x plus 2 square roots of x plus 2 equals negative x.
Maybe subtract x.
Okay, get rid of that x. So that's 2 square roots of x plus 2 equals negative 2x. Okay, now that radical's still being multiplied by 2, so we're going to divide everything by 2. So that'll cancel out, leave me with the square root of x plus 2 is equal to, negative of a positive makes that a negative x, doesn't it? Alright, so we're getting somewhere. It's been a long process. Okay, that radical's all by itself now, so it's ready to get rid of it. It's being square rooted, so we're going to square it. The square cancels the radical out. What does the square do to this thing? Good. It's x squared, but it's a negative squared, so that makes it a positive x squared. Negative times the negative is positive. Okay, we're getting there. I've been saying that a while. It's slow. Okay, it's up to you. I'm with y'all over there. It's up to you to decide which way do you want to move this stuff, because we got a quadratic, because we got a squared. My personal preference, I like my square to stay positive, so I'm going to keep that where it is, and I'm going to subtract this other stuff. Is that okay? So I'm going to subtract the x, so it's going to be x squared minus x, and I'm going to subtract the 2. It's easier, if it's because I'm dumb, I don't know, but it's easier for me to factor when my a is positive. A lot of people will look here and so they'll say, well, just subtract the x squared, that's only one step. I can't handle that as well. Maybe I'm dumb. Alright, can we factor this now? Okay, a times c is -2. Are there any factors in -2 that add to -1? -2 and 1. So I got x minus 2 times x plus 1. Set those both equal to 0 and solve. Is that what y'all got? 2 and -1? We got to check them now. I don't like having to scroll all the way back up. Let me write the equation we started with down here underneath it. Square root of x plus 2 plus 1 equals the square root of. Alright, which one are y'all checking first? 2. So 2 plus 2, plugging the 2 into both of them. 2 plus 2 is 4. Square root of 4 is 2. And then 2 plus 1 is 3. Here, 3 minus 2 is 1. The square root of 1 is 1. So I got 3 equals 1. Does 3 equal 1? Nope. So 2 is extraneous. It's no good. Okay, now I'm plugging a -1 in. So -1 plus 2 is 1. The square root of 1 is 1. And 1 plus 1 is 2. 3 minus -1 is 4. The square root of 4 is 2. So I got 2 equals 2. Yes, ma'am. -1 is your only solution. Now say that, what if I do what now? Well, that's what I did. That's why I put minus x here. I can't combine it because one of them's a square, one of them's not. Yeah, that's what I did. And then same thing when I moved the 2, I subtracted it. That's why they're both negatives here. I'm sorry, that's my fault. I didn't show that. I'll do better, maybe, if I forget. Alright. All of them so far have had radicals in them. We've also been talking about rational exponents, because remember that's your power over root stuff. So let's look at one that's got a rational exponent. These are easier in my opinion. All of it's been, that last one was the hardest. All of it other than that's been pretty easy.
Does it take a lot of room?
Not near as much, no.
Yeah, that took like half a Wait, what is this thing called? Maybe it's just my handwriting.
Rational exponents. So we got 2x to the 3/4 power plus 2 equals 10. Alright. Going to plan of attacks. We'll start off the same way as it did with the radicals. We're going to get rid of any extra junk. So I want to get rid of that plus 2. And I get rid of a plus 2. Subtract 2. So that gets me 2x to the 3/4 is equal to 8. Alright, now when we had radicals, we wanted to get rid of the radical after we got it all isolated. Same thing here. I got a rational exponent. I want to get rid of a rational exponent. When I have no exponent written at all, it's an understood 1, right? Like x is understood to be x to the first power, right? So how can I make 3/4? What can I multiply that by to make it become a 1?
Reciprocal.
Very good, Kylie. Thank you. Nobody ever remembers that. 3/4 times 4/3, that's 12 over 12, which is 1. Multiply a fraction by its reciprocal to get 1. So I'm going to raise this whole thing to the 4/3 power. Okay, so here, when I distribute that, the 3/4 and 4/3 is 1, so that's just 2x. And then I got 8 to the 4/3. Okay, so now I got to figure out what 8 to the 4/3 is, and you've got options on how to do that. You can get it in your calculator if you want to. Remember, power over root. I can do that power over root in my head real quick because that's a cube root of 8, which is 2. And then power 2 to the 4th is 16. But even if you don't remember that, you can get that in your calculator. 2x equals 16. What? You didn't
My bad. The 4/3. No, the 4/3 is x.
Got it? That's okay. What would your last, anybody else need assistance on that? What would your last step here be?
5 by 2.
5 by 2, so x would be 8.
Just put it right there again.
Yeah, it'd still be extraneous. So I'm looking here, 2 times 8 is 16. 16 to the 3/4. 8. Yeah, this 4/3, 16 is 2. 2 cubed is 8. 8 plus 2 is 10. So it does check out. 8 is correct. Not too bad. Not too bad. Alright, I'm going to give you one that's got radical in it and one that's got a fraction exponent in it to try. Number 1 here, we're staying simple, being nice to you. I got the square root of 3x plus 10 is equal to 8. And then number 2, where the fraction ones go? There we are. 4x to the 3/2 equals 32. Now I do need to caution you on number 2 up there. On the last one that we did, that whole 2x was in parentheses, so the exponent went to both of them. On that 4x, it's not. Are you with that? This exponent is only on the x here. Okay? So your extra jump to get rid of would be that times 4 on that. Feel okay there? Alright, see if you can get both of those knocked out. Hit it. The exponent, see here the exponent went on both of them. But on this one it's not in parentheses, so it's just on the x. How we doing? Say that again, Willis. You bet. First thing is, since that power is only on the x, that 4 is extra stuff to get rid of. So you divide by 4. Okay. Now you need to get rid of that 3/2 power. So what So raise everything to the 2/3 power.
Because you divide by 4 first. It's not much.
Yeah, so
You
it's
need to go to this.
what 8 2 2. You got it, dude. Alright, on the first one there, the square root of 3x plus 10 equals 8, was there any extra junk you needed to get rid of initially? No, there's nothing outside of that radical where the radical's already all by itself. So this was one of the short and easy ones. It wasn't that long foil one. We just need to get rid of a square root, and we do that by squaring it. Good. So square and square root cancels out. You just got 3x plus 10. 8 squared is 64. What do? We got a two-step middle school equation. Subtract 10. 3x is 54. Then what? Divide by 3. X is 18. Was that legitimate or extraneous?
Legitimate.
Let's see here. 3 times 18 is 54. Plus 10 is 64. Square root of 64 is 8. Good job. Alright, number 2. And I gave you the hint, the warning on that. If this had been written like this, there would not have been any extra junk, right? But since it wasn't, the 4 doesn't have the power, so the 4 is extra junk. So how do we undo a multiplication of 4? You divide by 4. So we got x to the 3/2 equals 8. Now I need to undo a 3/2 power.
You apply the whole thing to it.
Do the 2/3 power. Good. So 3/2 and 2/3, that makes 1. So we just got x. Then I've got 8 to the 2/3.
That equals 4. And it works.
That equals 4. So here I would do 4 to the 3/2, power 64, root 8. 8 times 4 is 32. Yep, that's 32. Good job. Much better on that today, you think? I like that a little bit better. I mean, yesterday was easy with the graphing, but I like that better than a couple days ago. Tomorrow, we're going to give us an assignment to look at, and then we're looking at, and we're going to have a test over this unless nothing disastrous happens the next Friday. Look it up.